Hello, this is Chemistry Central Science, 11th edition, and we are in Chapter 4 on the aqueous reactions and stoichiometry. This is the end of the chapter questions number 61 and 71. Calculate the molarity of a solution that contains 0.0250 moles of ammonium chloride in exactly 500 mils of solution. All right, so molarity is going to be molarity equals moles of a solute over liters of a solution. Okay, moles over liters. So we want to say how many moles do we have? So we're going to say the molarity equals 0.0250 moles. And how many liters do we have? They've given us 500 milliliters. Well, there's 1,000 milliliters in a liter. That means 500 is 1/2, so this is 0.5 liters, okay? So we have 0.025 divided by 0.5, and I have the molarity equals 0.05 molar. Okay, you see how easy that is? All right, how many moles are present in 50 milliliters of a 2.5 molar solution? All right, so that's what this is. That's molar. So we've got 2.5 molar equals moles over liters. Okay, so I've got 50 milliliters and I want to go to liters. Okay, so I'm going to move this over 3 times. 1, 2, 3. And I have 0.05 liters. Okay, so this is going to be, I want to solve for moles, so I'm going to multiply liters to get moles by itself. So I'm going to have 2.5 times 0.05, and I have 0.125 moles. You see, you're just solving for what they asked for. See how many milliliters of 1.5 molar, okay, so if we have 1.5 molar, that's what goes here. 1.5 molar is moles, okay, they give us that, so we have 0.275 moles over liters. Well, we want to solve for liters. So we go up and bring this one down, okay? So it's going to be 0.275 divided by 1.5. So it's 0.183 liters. Well, they're asking for milliliters, so we multiply by 1,000, 2, 3, and we have 183 milliliters. All right? Indicate the concentration. All right, the concentration is molarity. They're asking you for the molarity, so that would be like this first one where they're asking for something molar. Indicate the concentration of each ion or molecule present in the following. All right, so we have 0.25 molar sodium nitrate. Break sodium nitrate up, because as soon as you put it in, these are solutions, right? That's what this says, solution. That means it's in water. If you put sodium and nitrate in water, remember nitrate is the it's the heart attack guy, and sodium is one of the alcohol guys. So they're both in the pool. They will completely break apart, and it breaks apart as 1 to 1. That means if I have 0.2 molar of the molecule, that's like a peanut butter sandwich. I have 0.25 moles of peanut butter sandwiches. I have 0.2 moles of the left bread and 0.25 moles of the right bread. That means that this is going to be 0.25 molar of the sodium, and I'm going to have 0.25 molar of the nitrate ion as well. Okay. All right, B, 1.3 times 10 to the negative 2 molar magnesium sulfate. Well, magnesium is in group 2, so that's positive 2. Sulfate is negative 2, so it's a 1-to-1 relationship. That means it's the same. I'm going to have 1.3 times 10 to the 2 magnesium, 2 plus, and sulfate, 2 minus. Okay, exactly the same. Last one, 0.015 molars of sucrose, that's sugar. All right, so this one, it doesn't break apart. Okay, so that means it's the concentration of each ion or molecule. Since it doesn't break apart, it stays together. That means I don't break apart into anything. It's 0.015 molar. Okay, if it doesn't break apart and I have that much concentration, then I have that much concentration. It doesn't change. If you were to have one where one's doubled, okay, so something like where magnesium chloride, where magnesium is positive 2 and chlorine, I need 2 of them. When it breaks apart, I would have 2 of those. So I would have, say, 1 mole of the magnesium, but 2 moles of the chlorine. Okay, but we didn't have that question. All right, then, I'll see you tomorrow.